Hello, this is a talk on Arabic language computing applied to the Quran, a PhD research project by Kais Dukes at the Institute for Artificial Intelligence and Biological Systems at School of Computing, University of Leeds. If you Google Kais Dukes, you'll discover his website, which shows he's a financial software engineer in the financial industry in the City of London. He's also doing a part-time PhD. Unfortunately, he's very busy at work at the moment and unable to present in person, so I, his supervisor Eric Atwell, am presenting this for him. His challenge is to try and find an interdisciplinary approach to understanding the Quran, using ideas from Quranic studies, traditional Arabic linguistics, and computing research, computational linguistics, and hopefully feeding back to all three areas. The Quran is the last in a series of 5 major religious texts. Believers hold that God gave the message to the angel Gabriel to pass it on to Muhammad, to learn by heart, and then pass it on to all the rest of mankind. It's written in the language of 1300 years ago. All believers are supposed to try and understand the original text, rather than translations or interpretations, as they're known. It has guided philosophy, science, and many other aspects of knowledge, in particular Arabic linguistics, which has developed to try and help understand the Quran, and it's been the guiding light in theories of syntax, semantics, and discourse analysis used today on modern English linguistics as well. As far as computers are concerned, there are many websites where you can access the Quran, but you can only search for verse by verse. You can search for individual verses which contain a particular word. So it's basically Google-style searching. It would be nice, in theory, to be able to ask questions in plain English, like, how long should I breastfeed my child for? And then have an AI system which computes the meaning and finds the verse which has relevant meaning to answer the question. Machine learning works by taking data and then learning patterns and classifications in the data. If we augment the data with linguistic and semantic concepts, then the AI system can learn conceptual patterns. So, we need to augment the Quran text with linguistic annotations. However, this is challenging, as the Quran is written in a complex script with very difficult word structure or morphology, grammar, and semantics. Computational linguistics research methods offer a solution. We can get hold of the text of the traditional Arabic grammar textbooks, extract the meanings of the grammatical descriptions, and use this for machine learning, and then put the results online for volunteers to correct. The first task is to get hold of an authentic version of the text. If you just use modern Windows encoding or Unicode, this does not display the original text correctly. Luckily, there was a project called the Tanzil project, which started around the time Kai started his research effort, which came up with a Unicode XML encoding which allows the text to be displayed authentically in its original format on a web page. So, Kai had to start by developing a Java API, or large set of code, which allowed you to read this XML and display the original text authentically on a web page. This then allows us to do morphological analysis as a next stage, and there are tools for morphological analysis of modern standard Arabic, and there has been some progress on analysing the Quran at the University of Haifa, and there are also some formal lexical representations developed at Columbia University. The trouble with the Haifa corpus is that it didn't really complete it, so each word has many possible analyses, and they're not verified by experts who know what was correct. And it's a non-standard annotation scheme. So Kai's answer was to develop the Quranic Arabic corpus website, do a lot of analysis, put it all online for people to see and use, and correct if necessary, including word structure, word-for-word translations, grammatical and semantic representations. So here we have the base, the verified Uthmani script for a word. You have to read the Arabic from right to left. Of course, if you don't speak Arabic, this doesn't mean much to you. But if you do speak Arabic, you can see this is the correct original format. For non-Arabic speakers, there's also a phonetic transcription, not using true international phonetic alphabet, but something like the standard Roman alphabet. So English speakers, if you learn English as a second language, you can probably work this out. Also, the assumption is that an awful lot of learners of the Quran do speak English. So we've added an interlinear word-by-word exact translation of what the Arabic morphemes mean. And there's a referencing system which allows you to locate any particular chapter, verse, word, and even segment, so you can find others which have the same uns, a complex referencing system. Now on top of that, each Arabic word is quite complex, so a typical word may have a root, for example a verb, and then a conjunction at the start of it, and then a subject and object pronoun after it. So you have to segment the word into individual parts or segments. And there's quite a lot of detailed information as to what the grammatical categories of the individual parts are. So this is it. Reading from right to left, a conjunction, followed by a main verb, followed by a subject pronoun, followed by the object pronoun. And for use by Arabic grammarians, as there are an awful lot of Arabic grammarians in the Arab world who prefer to speak Arabic, there's also an automatically generated Arabic translation of the grammatical description on the right-hand side. Somewhat more complicatedly, there's a parse structure tree or diagram showing the grammatical structure for each sentence, based on the traditional Arabic grammar or Arab rather than modern linguistics. There's also quite a complex ontology, which is the set of all the entities or things. Every noun or pronoun refers to something, and this is linked to from the text, so you can find all the instances of that from the ontology. On top of it, there's quite a complex framework for collaboration, a message board so that anybody finding anything wrong can point it out, and a large set of downloadable resources, including the software and the data and other things too. This is used by researchers and members of the public worldwide. This map from the website shows there are many users, many in America and Britain, but also around the whole world. And these are not just lay people trying to read the Quran, but many researchers worldwide. So, as far as AI and computational linguistics, what is new? Well, it's the first tree bank of parse trees for classical Arabic, and it's the only one that's freely available. There's also formalism for traditional Arabic grammar used in machine learning parsing. And this is a novel part-of-speech tagging system. So for each word there's quite a detailed grammatical category gleaned from traditional Arabic grammar textbooks, but formalised in a computational sense. Kais has also developed a parser which takes examples of these trees and can use machine learning to work out the patterns for parsing and then apply the parser to new sentences, such as other classical Arabic sentences from other classical texts. So, how do we meet the criteria for Postgraduate Researcher of the Year? Able to communicate research to the lay and non-specialist audience, impact on the rest of the world, engagement to the public? These are all important. Well, there is a feedback page on the website that includes hundreds of feedback messages from members of the public, but also from some academic researchers, particularly non-specialists, such as Professor Michael Arthur, Vice-Chancellor of Leeds University, and others too. In terms of impact, over 1 million users have used the website in the past year alone, and obviously it's just starting, so there'll be many more. And there are lots of interesting users, such as a chaplain in the Correctional Centre of the State of Missouri, a really interesting example. Scientific impact in terms of the subject area? Well, he's already published many papers, including a significant journal paper, quite a few citations, even though he's only halfway through his PhD, and lots of positive feedback from other researchers around the world. And news articles, for example, the Muslim Post, and the website itself has got a lot of public users, and the feedback is definitely public engagement on a worldwide scale, shall we say. So to conclude, well, this is not the end. It's only halfway through his PhD project, given it's a part-time PhD project. So I hope you are going to give him the award of Postgraduate Researcher of the Year. If not, he can always come back